Okay, here's part 2 of tissues. So this is on connective tissues. And connective tissues are like second most numerous compared to epithelial. So these are your 4 main types of connective tissue. The connective tissue you think of, and then cartilage, bone, and blood is technically connective tissue. And the major functions you need to know: binding and support, protecting, insulating, fuel reserve, and then transporting stuff, which is what your blood does. So here is connective tissue. There's a few different types of connective tissue. The loose kind is areolar, adipose, and reticular. And then the dense connective tissue is regular, irregular, and elastic. So we'll learn about those types. And then cartilage can be hyaline, elastic, or fibrocartilage. Bone can be compact or spongy. And then blood, you'll learn more about blood later, but it's technically a connective tissue. Okay, so there's 3 things that make it connective tissue and not something else. They have a common embryonic origin, so they come from like the same tissue type, and then they differentiate into other types. They are vascularized. Cartilage technically isn't, though. That's why cartilage, you have a harder time healing if you injure cartilage than if you injure like bone or muscle. And then the cells are in an extracellular matrix that provides a lot of support to those cells. Okay, and there's 3 main things that all connective tissue has: ground substance, fibers, and cells. So the ground substance is like just jelly goo that's in between the cells. It allows stuff to diffuse through and move through the cells. It's made of interstitial fluid, cell adhesion proteins, which sticks them together, sugar proteins, and then water. So here are 3 types of connective tissues that do support. We've heard of collagen already, so that's the strongest, most abundant, and that's going to be under your epithelial tissue and give you support. And then elastic fibers give you like stretch, and then reticular, and they are different from collagen, and they kind of branch and support. Okay. The types of cells you have, so you're going to see this suffix a lot: blast cells, and site means cell also. Blast cells are when they are immature. So you've got fibroblasts, you've got chondroblasts, and you've got osteoblasts. And those are growing like the tissue, okay? And then sites are the ones that are just kind of there taking up space and giving support and kind of making up the matrix. So the blasts are the ones that are actively growing, and the sites are just there for support. So you'll look for those prefixes, you'll see them a lot. Okay, other types of connective tissue: you've got fat cells, white blood cells, mast cells, and macrophages. You've probably heard of some of these. So fat cells are literally just cells that have fat in them, used to store nutrients. White blood cells are for immune support, and there's immune response, and there's different types of white blood cells that we'll learn about later: neutrophils, eosinophils, and lymphocytes. And then mast cells help with immune response, like inflammatory response. And then macrophages eat stuff. They eat bacteria, they eat other cells that need to be recycled. Okay, so this is what your extracellular matrix looks like. There's a fat cell right there. You can see a capillary, which are 1 cell thick, so stuff can diffuse in and out. This is a type of white blood cell, a neutrophil. Mast cell right there. I can't tell what that one's labeled as because I can't see it. And then you have different types of fiber. So you can see they have like different structures: reticular, elastic, collagen, and thus different functions. Okay, so 4 main classes, like we said: connective tissue proper, cartilage, bone, and blood. And this is how they're categorized, which you saw in that other graphic. So you have loose and dense connective tissue, and these are the 3 types of each. And then you have cartilage, 3 types, bone, and blood. Okay, so connective tissue is everything except for bone, cartilage, and blood. And you've got those 6 types. The loose is areolar, adipose, reticular. Dense is dense, regular, irregular, and elastic. Okay, so areolar is first. This, I think, is the most common type. It's kind of looser, provides support. Macrophages and fat cells kind of sit inside of it. So it's like a good way to think of it is packing material. So here's what it looks like. You can see the ground substance there. You can see the little nuclei, the fibers. You can see collagen right here, the pink. and it's just like a matrix that holds everything and gives it support. Okay. And then adipose tissue, you probably recognize that word maybe. It's white fat. The cells are called adipocytes. Remember sites, that means cell. It's not as it doesn't have as much structure as the areolar. So it helps with shock absorption, insulation, energy storage. And then there's also brown fat. So you have both, and that helps you get energy. You can convert it into ATP. So here it is. Those are your fat cells, little fat droplet, and there's a nucleus. So it is like a little fat cell. Okay, reticular connective tissue is similar to areolar, thinner fibers. You saw that in that other picture, the little skinny, I think they were purple fibers. The cells are called reticular cells. So skinny little cells of collagen. It gives you like a mesh, gives support to blood cells in your lymph nodes, spleen, and bone marrow. So here they are. And see the reticular fibers. They're just like stringy, like there's a whole bunch right here, but they're just stringier. Okay, so that's what that looks like. All right, then you've got your dense connective tissue. So you've got your three kinds there. Dense regular has high tensile strength, so lots of tension, stretching, not very vascularized. This is your tendons and ligaments. So that's why when you injure a tendon or ligament, it takes a long time to heal. It's really difficult to heal because it doesn't have a lot of blood flow to it, right? They're going to look white and wavy. So here they are. That's what they look like. There's the nuclei. They're like long and skinny, and they're just kind of white and wavy. And that's what you might have pictured ligaments and tendons to look like. And a ligament connects bone to bone. A tendon connects muscle to bone. Okay. Then you have dense irregular tissue. So this is similar to regular, but it's not as organized. So sheets rather than bundles, resist tension in many directions. So like joint capsules, it's in your dermis. So let's look at it. So you can see it doesn't look as organized, but it is similar. It's wispy. You can see the nuclei, but they're not skinny. So joint capsules in your shoulder and things like that. And then elastic connective tissue is a lot stretchier than the other two. It's found in in your vertebrae, in the ligaments that connect your vertebrae when you need your arteries to stretch out. So it's a little bit more elastic than the others. Here's what it looks like. So you can still kind of see those strips of fibers, and it stretches really well. And this is a good example of structure and function. Like you can just look at the structure and tell that the function would be like a stretchy action. Okay, then we're moving into cartilage. So cartilage is the two types of cells are chondroblasts and chondrocytes. I think that we haven't seen that yet, but chondro, that prefix means cartilage. And then the blasts are the growing ones. The cytes are just like they're doing their job. Mostly made of water. It's got collagen. They're really strong, but they're flexible. Doesn't have nerve fibers, so when you damage your cartilage, if you've ever done that, you don't really feel it. Also avascular, so you're not going to have good blood flow either to your cartilage. So three types here. Hyaline is most abundant, known as gristle. If you eat gristle off a chicken leg, that's what you're chewing up. Shiny, right? It's the ends of your long bones. It's in your nose, so when you break your nose, you might be breaking your hyaline cartilage. Tracheolarynx and cartilage of ribs. And then elastic, not as common, but it's what's in your ears and epiglottis. And then fibrocartilage, like in your knee, in your vertebral discs. So this is hyaline. And you can see what the little cells look like. So there's your matrix, and then these are the little chondrocytes. And then this is elastic. So the structure looks a little different. You can still see the matrix there. The elastic fibers, and then this is a chondrocyte. That's in your ear. And then this is your fibrocartilage, so in between your vertebrae. Okay, so It doesn't heal as well as we get older. You can't heal injuries as well, and that can become a problem. You can have problems like osteoporosis and things like that. Okay, then bone is the next connective tissue before blood. It's also called osseous tissue. If you see this prefix osteo, that's bone. So supports and protects, stores fat, makes your red blood cells, which we've learned all of that already. It also stores calcium salts. And these are the two cell types. Osteoblasts are the bone building cells, and then osteocytes, they're just the mature ones. There's also osteoclasts that we'll learn about later, and they destroy bone. Okay, so let's look at this. So they are highly vascularized, way more than the other connective, than the two that we just looked at. So they do have an easier time healing if you break your bone. And they have this like concentric structure, like these circles that we'll look at more later. But those are all made of bone cells. Bones are living. Sometimes we don't think of it as alive. They are living, breathing cells, just like the other cells. And then blood. Blood is weird. It's weird that it's called a connective tissue, but it is. In your blood, the most common cells, I think probably 50% of your blood roughly is red blood cells. And then you've got some white blood cells and some platelets. And then you've got other stuff in your blood that hangs out in your plasma, like nutrients, waste, gases, other things. So these little red things are red blood cells, and they have this really unique shape where it kind of looks like a filled-in donut. And they're kind of like a little flotation device, like if you go floating on the river, they kind of have that same shape, except they're solid in the middle. So that allows them to bounce through blood vessels and get through. And that's a really good example of structure and function. And then these are white blood cells here. And remember, there's different types that we'll learn about later. So these are neutrophils and lymphocytes. Okay, now let's move into muscle tissue. Muscle tissue is another type of tissue. We got muscle and nerve left. So muscle tissue are made of myofilaments. Excuse me. Myo, that prefix means muscle. And they're made of proteins. So muscles are primarily built from proteins. If you're trying to build muscle and you're eating proteins, you're doing the right thing because that's what they're made of. The proteins are called actin and myosin, and they're the ones that are actually contracting. And muscles are highly vascularized, so that means they have a lot of blood flow. Here's your three types: skeletal, cardiac, and smooth. So skeletal muscle attaches to your bones via tendons. Tendons kind of serve, I think of it like a ponytail, grabbing the muscle fiber and then plugging it into the bone. And they are voluntary. Skeletal muscles are voluntary, so that you consciously control them. The other two types of muscles are involuntary. These are special muscle fibers where they contain multiple nuclei, and it looks like they have stripes or bands, and so they're called striated muscles. So there you are with the stripes and bands, and that's actually what's doing the contracting. When your muscle contracts, it's those stripes getting closer and then lengthening. And those are the nuclei. Cardiac muscle is only in your heart. You also have other types of muscle in your heart, like smooth muscle. Just smooth muscle, you don't have skeletal. So this is involuntary. It's also striated. So it's striated like skeletal. The only one that's not striated is smooth muscle. And these cells have one nucleus instead of many, so that's a difference. And then there's a special joint where they connect called intercalated discs. So here they are. You can still see those striations, but it looks a little bit wispier, not as organized as the skeletal muscle. And the way that it's controlled is also a little bit different because it can be zapped with electricity and it contracts really efficiently that way. And then smooth muscle is only in organs, hollow organs, blood vessels. It's involuntary. It does not have striations, so it's built different. It has a different structure. And it looks kind of spindly, one nucleus. So there they are. You can't really see it, but if you look at this picture, they're kind of spindly, right? You do have some smooth muscle in your heart too, in like the blood vessels. And then nervous tissue. So nervous tissue is brain, spinal cord, nerves, controls your body. The cells are called neurons. They're the ones that conduct nerve impulses and action potentials. And then you also have supporting cells that are kind of the helpers. They protect, support, insulate the neurons. So this is what a typical neuron looks like. So you have a cell body and then the tail. They don't all look like this though. This is just like your standard picture, but there's a lot of variation. So here's some neurons, and then you can see the other cells there that are supporting them, like the glue that's kind of holding them together. Okay, and then these are different types of coverings and linings, and they are made of like combos of two. They're made of epithelium and connective tissue. And we've seen some of these terms before: cutaneous, mucous, and serous membranes. Okay, so cutaneous membranes is skin. It's a dry membrane, so that's unique. And in your skin, which we'll learn about more later in chapter 5, I think, you've got epidermis and dermis. Epidermis is on the top, and then dermis is underneath. So there you are showing your cutaneous membrane. And then you have mucous membranes. Those are like the opening, like the holes in your body that open to the outside. Generally contain mucous membranes, and that's to protect your body from like the external environment so that it can trap what gets in. So they line body cavities like digestive, respiratory, or genital. Any hole that opens out to the outside is generally a mucous membrane. So nose, mouth, eyes, ears, urogenital region, all of that. Okay, so they're moist membranes. They might make mucus and they protect you. So there they are. They're opening to the outside, and they need that mucus to protect them from what's on the outside. So it can't get into the inner part of your body. And then serosae are in your ventral body cavities. We've seen this term before. They're usually made from simple squamous epithelium, and then they have areolar or connective tissue on top. That's why these are so common, because it's like lining everything. So lining internal body cavities, internal organs, they have different names. Like your lungs is called pleurae, pericardium is your heart, peritoneum is your abdomen. So it has different names, but it's the same thing. So there they are. They line the inside there. They reduce friction. They protect it. They allow you to move around. Like we are able to be really active because of this tissue that lines our organs. Okay, and then tissue repair. You have to be able to protect yourself from foreign pathogens. And so we have inflammatory responses. That's the first line of defense. And then we have immune responses. And then we can repair any damage that was done. So there's different steps to this. You can either have regeneration, which is where you're going to replace the tissue, or so if it's regeneration, it's replacing it with the same tissue. Fibrosis is replacing it with connective tissue, and that's kind of like, you can think of like scarring. And so if the tissue isn't the same as it was, doesn't function the same, the structure is different. So step one is inflammation, and that's a protective mechanism. Your body does that to kind of like pause everything in that site, and then your immune system can get in and respond and heal it and get everything there that needs to. So it's kind of like if there's an accident, the cops surround it and make sure everything's secure. And so one of the things you do is dilation of blood vessels, and that means the blood vessels get bigger, and that's going to allow all the things to get to the site that need to. And then your blood vessels become more permeable, so stuff can get into that tissue and heal it. And then blood clotting also occurs. Like if you break a bone, the purpose of inflammation is to keep that bone steady, kind of like a splint, to keep it still, so that, and then we go in and splint it ourselves and cast it and everything. Okay, so here is inflammation. So you can see the tissue, these inflammatory chemicals. This is cell signaling that we learned about before. So that's going to tell all these cells to show up and get to work. Then you have organization. And so the blood is clotting, and then that's going to get replaced with granulation tissue. And then the epithelium is going to start to regrow. If it's if it's going to be replaced with collagen fibers, they're also going to show up. So it's going to kind of stitch it together in that area. And then if there's any bad stuff, if there's any foreign debris, it's going to be phagocytized, which means the macrophages are going to come in and eat the bad stuff. So here it is. It's like stitching it from the bottom, and it's creating that matrix to kind of stitch it up there. It's very cool. Then you have your scabbing. So regeneration and fibrosis, depending on like how bad it is. So remember, regeneration is original tissue. Fibrosis is like cartilaginous tissue that's going to come in and make like a scar. Sometimes the scar tissue isn't visible. If it's bad enough, it will be. So there it is. It's going to stitch it back. It may not ever look like it did, or like here we have regeneration because it's epithelium, but it may not be. Okay, so some tissues are really good at regenerating and healing, and some are really bad at it. So epithelial, bone, areolar, dense, irregular, and then blood-forming tissue, those are really good at regenerating. Smooth muscle, dense, regular connective tissue are really bad. I mean, not as good. And then some can't really repair at all. So cartilaginous tissue is also not great at repairing because it's not vascularized. But cardiac and nerve tissue are not, like most of the time, not going to heal really at all. So that's why if somebody's like paralyzed, often there's no hope of that healing. But they are trying to find ways to make it heal better. Okay, so scar tissue can have a different structure than the original and therefore have a different function. So the organ may not have its same volume capacity. It may not be able to move, block stuff from moving. It could interfere with how the muscles work, or it could pinch nerves and things like that. And so your tissues are not going to work like they did originally. Sometimes scars stick to other organs. You've probably heard of that, and that can inhibit their function. It can even lead to organ failure, like in the heart if you've had a heart attack. Okay, so these terms deal with the development of like embryos. That's how we use these terms. So we have ectoderm, mesoderm, and endoderm. And so in a developing embryo, you have these different layers. In a very young embryo, they don't look like they're the organs that they're going to be. But the ectoderm forms nervous tissue and skin, like the outside. Ecto means outer. Meso is going to form your muscle. I think, yeah, endoderm I think is digestive system primarily. So that's where those 3 layers are going to form from, and then epithelial is from all 3. So that's what happens when an embryo is forming. So usually when you're young, your tissues function really well, and then as you age, they start to function less well. You're not repairing them as well. Your bones and muscles and nervous tissue atrophy. You're more at risk for cancer, so things start to break down as you get older. Let's see. Yeah, these are the layers in an embryo. This is a really early 16-day-old embryo. So ectoderm is right here. That's going to form your skin and your nervous tissue. And then muscle and connective tissue is mesoderm. And then endoderm is digestive lining. I think that's what I said. Yeah. So then all 3 are going to form epithelium. But those are what those 3 layers are. And then pretty soon it's going to look like a little embryo, like a little fetus. And that's all of tissues.